Hi folks, welcome to 1.2 Domain and Range. And so today we're going to take a look at what we know first, right? It's always a good practice to kind of think about what we've done so far so that we can tie it into where we're going. And so what we know so far, we've talked about relations. We've talked more specifically about, is the relation a function or not, right? And we know how to do that in a few different ways. And then if it is a function, is it a one-to-one function or not? And then we talked about some other questions that we should ask ourselves if we wanted to address that question. All right, so we've talked quite a bit about relation. We've talked about maybe something we can collectively say as multiple representations, right? The mapping diagrams, tables, graphs, and equations. And then we started to dip into some of that algebra. How do we find f of x if we're given an x? And then how do we do it the other way around? If we're given the y value, how do we find the x value? All right, so that's a summary of what we've covered in 1.1. And what we're moving on to today, is talking about what's new, all right? So what is new today? We're going to build on finding domain, all right? But we're going to look at domains of functions of just from equations, all right? So we get a chance to practice from equations. We're going to find domain and range from some graphs. And lastly, we're going to study something called piecewise functions, right? And just so you know, you can find this in the first part, in the first video, or part 1. This will be the video part 2, and this will be the video part 3, okay? All right, let's get started. Finding domain algebraically, all right? So finding domain algebraically really means find the domain if you have an equation. But I thought it would be good for us to start off with something maybe a little bit more familiar. List the domain and range of this relation, right? So we talked about how relations are ordered pairs, and we can see 5 ordered pairs right here. And our domain is really going to be all the first numbers in our ordered pairs. And then our range, all right, is actually going to be the second number in the pairs, in the ordered pairs, all right? So we've got our domain and our range, but if the question asks us to list it, we actually have to write them out, okay? And just as a reminder, if we wanted to write our domain, we would have squiggly braces, and then we would list all of these numbers in orange from smallest to biggest. So -5, 0, 5, 10, and 15. That would be the domain. And the range would be all the blue numbers, but from order of smallest to biggest. So -12, -8, -4, 0, and 4, all right? And so that's usually how we list them. We just write them out inside the squiggly braces, and we've got domain and range usually in order from smallest to biggest, okay? Now, if we have ordered pairs, it's pretty straightforward, right? We pick our domain, we pick our range. So our range and our domain. But when we only have an equation, like examples 2 and 3 here, can actually become a lot trickier. I mean, one thing we could do is just start making a table, list out all of the numbers that we know, and just try them all. And that's what we call brute force method, right? It's just a lot of work. You're going to do the same procedure over and over again. But maybe, just maybe, there's a more clever way to do that, okay? Because we don't want to sit and try all the infinite possibilities for X and just kind of hope that we find something that works, okay? And so I just wanted us to see these examples as ones of algebraic equations, but I think what I'd like to do is actually talk about a general strategy that I find really helpful when finding domain of just an equation, okay? So I look at this in sort of 3 steps, right? Step 1, do I see any fractions? All right, do I see any fractions with the variable in the denominator? All right, so that would be the first question that I ask myself. Do I see any fractions with the variable in the denominator? The reason why I like to ask myself this question first is because one thing that maybe we remember from a previous class, okay, we cannot divide by 0. All right, we cannot divide by 0. So if we see a fraction that has a variable in the denominator, so we cannot divide by 0, so set the denominator equal to 0 and solve for x. And solve for x or your variable, whatever your variable is, okay? So we cannot divide by 0, so we set the denominator equal to 0 and solve for x, all right? This gives us values that are not in the domain, right? This gives us values that are not in the domain. All right. Let's pause here for a moment. Let's go back to example 2 and 3. All right, so I see in example 2, I have a fraction. And example 3, I do not have a fraction. All right, so the strategy we just talked about will work for this f of x, but it's not necessarily the best thing to use for g of x, okay? All right, so let's show how we would get started for something like this. To list the domain of f of x equals x plus 1 over 2 minus x, I see that there's a fraction. So I'm going to take the denominator. All right, we're going to take the denominator, and we're going to set that denominator, 2 minus x is going to equal 0. And I'm going to get x all by itself, right? That's what it means to solve for x. Now, the easiest way I can do that is actually to add x to both sides. Plus x, and I get 2 equals x. Now, that means that 2 is not in our domain, okay? So 2 is not in the domain. The reason it's not is because 2 is the number that makes the denominator 0, and we cannot divide by 0, okay? Now, 2 is the only number that we get when we solve for x on the bottom, when we set it equal to 0. Since 2 is the only number, really our domain is everything except for 2. And the way we write that, right, our domain, we say from negative infinity to 2, close it in union with 2 to infinity. All right. Now, if there was another number, we would have to have more unions so that we could break it up piece by piece, right? But for right now, for this particular question, we just have the 1, we exclude that 1, that is how we list our domain, okay? So that's a great strategy anytime we have a variable in the denominator of a fraction, right? But as we said, example 3 doesn't have a fraction, right? But it also looks a little scary because it's got the radical. So for general strategy, the second question I actually ask myself, right, is not do I see fractions with a variable in the denominator, but do I see radicals with even roots? Okay. Now, what I mean by that, maybe I'll continue to write this in the blue, is a square root, right? There's secretly a 2 there. It could be a 4th root. It could be a 100th root, okay? Well, any even number in this root, we can sort of treat with the same strategy we're going to see right now, okay? So if you see a radical with even roots, then what you're going to do is this. You're going to remember that we cannot take an even root of a negative number. All right, we cannot take the even root of a negative number. If we did, we tried to take like the square root of -4, and we put that into our calculator, it would give us an error. Okay, and in fact, those are something we call those imaginary numbers. But when we're looking with these, we want to look at real numbers. Okay, so we cannot take an even root of a negative number. So set the radicand, that's a very fancy word for the thing inside the root, right? Set the radicand greater than or equal to 0 and solve for x, okay? Now, the reason we are doing this is because the thing inside the square root, when all is said and done, cannot be less than 0. It can equal 0, and it could be bigger than 0, but it cannot be less than 0, okay? So remember, the square root of 0 is 0, so that's why it's okay to equal 0. Well, knowing that, let's go back to our example 3. Right? We said example 3 was not like example 2. It did not have the fraction with the variable on the bottom. And so since we notice that we've got a square root here, we can actually take this radicand, all right? So this in the yellow is what we call the radicand, right? It is the thing inside the square root. We take that, 5 plus 2x, and we make it greater than or equal to 0. And from here, we solve for x. So I'm going to subtract 5 from both sides. 2x is greater than or equal to -5. And I'm going to divide both sides by 2. X is greater than or equal to -5 over 2. Okay. Now this is all the values that do work, meaning they are in our domain. Okay, so that's a little bit different from the other way when we had the fraction. The number we found was not in our domain, but here what we're getting is all the values that do work. Okay, it's all the values that do work. So our domain for this one, it's everything bigger than -5/2, but also including 5/2. So we're going to have -5/2 with a bracket. The square bracket shows that we're including it, comma, all the way up to infinity, close it with a parenthesis. Okay? So this is our domain for something that has an even root. And that is number 2, shows us the domain when we have a fraction with something in the denominator, okay, that has a variable. All right, now that's only 2 special cases, right? But let's take a look at example 4 for a moment, all right? It says list the domain and range of h of x equals x squared minus 1. Well, if I think about my strategy, I don't see any fractions with a variable in the denominator, and I don't see any roots, any like radical symbols, okay? So what that means is we're actually going to try our third strategy. And I ran out of space above, so I'm just going to list this as number 3 down here, okay? So we've got our first question, our second question, and the third question we'll write down here. All right, so this third question, what I like to ask myself once I've asked myself the other two is to think about numbers in clumps, all right? So think about numbers in clumps, okay? And here's what I mean by in clumps. I mean, I don't want us to sit and think about every single number that possibly we could plug in. That seems, again, like that brute force method. Too much time, too much effort, not enough payback. But if we think about numbers as like, let's think about all the positive numbers. Let's think about all the negative numbers. And then let's think about all like 0. Can we plug that in? That can usually tell us whether we have any exceptions or not, okay? So the first thing we're going to do is think about if we can plug in a positive number, any positive number in for x, and it works every time, we're good to go, right? So I notice here that I have x squared, and then after I square it, I'm going to subtract 1. So the question for positive is really, can you square a positive number? And I think if we all took a moment and thought about a different number, like 4 is a positive number, 4 squared is 16, totally can do. Or if I chose 1 is a positive number, 1 squared is 1. That's fine, okay? I can square any positive number, so that means all the positive numbers are part of the domain, okay? I like to think about 0 next, only because if I don't think about it next, I often forget it, all right? So now it's like a special case. Can I plug 0 in? Is that going to cause me any problems? Well, 0 squared is 0, so that's fine. I can square 0, all right? And the last clump I think about is negative numbers, all right? So can I square a negative number? Well, if I had -3 and I squared it, I would get 9. Or if I had -5 and I squared that, I would get +25. So sure, I can square a negative, right? If you get a yes for all of these, what that translates into is a domain that is everything. So from -infinity all the way to +infinity. Right? And that can be a pretty common domain when we're looking at some functions that we've studied maybe in previous classes that feel more familiar, okay? Now that is the domain. How in the world might we find the range, okay? Well, let's think about this, all right? I've got x squared minus 1. X squared minus 1. Well, if I square x, I'm always going to get a positive number. But I wonder, what's the smallest number I can plug in for x to get the smallest value for x squared, right? And it turns out that that number is 0. So if I plug in 0, I get 0 squared minus 1, which is -1. -1 is the smallest y value that I can get out. Because after that, I'm just taking a bigger number and taking away 1, okay? So since -1 is the smallest number, my range is from -1 up to infinity, okay? Now, I think for some of us, this makes quite a bit of sense, how we reason through finding a domain and range, but I will admit that it is challenging to find domain and range from just the equation. All right, it really pushes us, and it's a good place. We should grow. It's okay for it to be hard, but it can be hard to just look at an equation and know. All right, so that's where we're really going to be practicing that. And I would challenge you and encourage you to practice it, even though it might be hard. Okay, but this is it for part one. When we come back for part two, we're going to take a look at how we might find domain and range more simply from a graph. All right, so I'll see you folks back here in just a little bit.